In lesson 12, we're going to look at a couple of proofs about quadrilaterals. So first thing that we're going to look at is this example that all rectangles are parallelograms. And so what you want to do here when you're trying to prove a conjecture, okay, so something that we think is going to be true in all cases, you want to figure out what it is that you're starting with and what you're trying to show. Okay, so what do you have and what are you trying to prove? So kind of what you have is the first part. Okay, so we're talking about all rectangles. So we're going to know that we have a rectangle and we're going to be trying to prove that the rectangle is then also a parallelogram. So if you want to try to organize your information like this, okay, so what do we know again? Okay, so we know that we have a rectangle. And then ultimately we want to show that we have a parallelogram. And so we're going to have to kind of see what would it take to prove something is a parallelogram and what do I have based on this vocabulary. So you can draw yourself a diagram, okay? So if we draw a diagram, again, we have a rectangle. So we're starting with a rectangle. So I'm just going to draw a rectangle, put some letters on it. Some things that I know from a rectangle, okay? And I know that a rectangle has 4 90-degree angles. So I will just mark those angles in here. This is what I have to start with. And then we need to show that it's a parallelogram, but how? How do you show that something is a parallelogram? And you do that by showing that both pairs of opposite sides are parallel. Okay, so you want to show that opposite sides are parallel. So in this diagram here, okay, that would mean that you're showing that AB, specifically AB, is parallel to CD, the one across from it, and that BC is parallel to AD, the one across from it. So we're trying to show this is parallel to this, and this is parallel to this. So that we don't know that yet, that's what we're trying to show. So then you got to think about, how do we actually show that lines are parallel? What are the ways that we know to show that lines are parallel? So here are some ways that we know how to prove that lines are parallel. So if we were to see alternate interior angles congruent, then the lines would be parallel. So that might show up like this, or in a quadrilateral, it might show up with a diagonal, seeing this angle congruent to this angle. Okay, which would prove those top and bottom lines are parallel. Could show up potentially like this in a parallelogram if you had an extension, see some corresponding angles congruent, okay, or like this. Another way that we know to prove that lines are parallel is that they are perpendicular to the same line. Okay, so both of these two lines are perpendicular to this one, so they have to be parallel to each other. So it looks most like this one. So let's take a look back in our rectangle. So we can kind of see that, where if we took a look at these lines here, okay, so we see for BC and for AD, they're actually both perpendicular to AB. So they're both perpendicular to this line. That means they're parallel. So we would be able to use that in our proof. And then also AB and CD are both parallel to BC, so we would be able to do that as well. Okay, so let's get that written into a proof. So what we used were the right angles, so we're going to have to start with what we know. Okay, so we know ABCD is a rectangle, which tells us that angles A, B, C, and D are all right angles. Okay, so that was from what we knew about it being a rectangle. So because it's a rectangle, then we know all of this stuff. So then what we did there is went on to prove that the lines were parallel. So then we said BC, okay, so line BC and line AD are both perpendicular to line AB. Therefore, BC is parallel to AD. Okay, so BC and AD were both perpendicular to AB. That means they're parallel. And then we can also do the other one. Okay, so we can also say, all right, so now that we got this top and bottom parallel, we can look at this one. So these two are both perpendicular to that top line. So we can say that one as well. So line AB and line CD are both perpendicular to line BC. So therefore, AB is parallel to CD as well. So now you've gotten both sets of opposite sides parallel. So now we've proven that, okay? We've gotten that into our proof. So we proved both of these things. That means that we're ready to say that it's a parallelogram, okay? Therefore, ABCD is a parallelogram because both pairs of opposite sides are parallel. And you definitely showed this in your proof right here and right here. Okay, so using what you were given, and then you figured out how to get what you needed, okay, and you proved it with some facts. So that's the idea behind a proof. So that's on page 250 in your student workbook, and we're going to take a look at a couple more. So another one on that page is if a parallelogram has one right angle, then it's a rectangle. So let's take a look at again what we know. Okay, so in this case, we know that we have a parallelogram with one right angle. So then we're trying to prove that this is a rectangle. So let's draw a picture of this. So we know that we've got a parallelogram and then we've got one right angle. Okay, so we know all the properties of a parallelogram still as well that we can use here since we know it's starting as a parallelogram. So a couple of things that we know about parallelograms is we know opposite sides are parallel, we know opposite sides are congruent, and we know opposite angles are congruent. So that's all from it being a parallelogram. In order to prove that it's a rectangle, we need to prove that we have four 90-degree angles. So in this case, we need to prove that angle B, angle C, and angle D are all right angles. We need to get all of these as right angles in our proof. So if we take a look here, kind of some ways that we'll be able to look at this is when we talked about the properties of a parallelogram, well, opposite angles are equal to each other. So I do know that this one's going to be a right angle from opposite angles. So then I just need to figure out how can I get angle B or D to be a 90-degree angle, because then the other one would be. So that's kind of the point that we need to get to. And so a couple of ways you could think about that. So if we think about back to the last proof, so we know that this line is parallel to this line, okay? And then we also know that AD is perpendicular already to AB. So that means it would have to be perpendicular to BC as well since these are parallel. So then that would make this one a right angle. And then again, opposite angles would be equal, would get us the rectangle. So let's start putting this into a proof. So I know ABCD is a parallelogram and angle A is 90 degrees. Okay, so that's kind of what you're starting with. So then you could start by saying this angle C. So you could say angle C I know angle C is 90 degrees because it is equal to angle A, since opposite angles in a parallelogram are congruent. Then how did we talk about getting angle B to be 90 degrees? So we said line AD is perpendicular to AB, and AD is parallel, and since AD is parallel to BC, then BC would also be perpendicular to AB. Okay, so since AB and AD are perpendicular, AB and BC are parallel, then BC and AD have to be perpendicular. This means that angle B is a right angle. Okay, then since angle B is a right angle, I know angle D is a right angle also. Because again, opposite angles in a parallelogram are congruent. Okay, so now we've gotten angle C to be a right angle, and then we got angle B to be a right angle, which then gave us angle D. So all of that is in our proof. So we've got all the angles being right angles, okay? So then we're able to say that it's a rectangle. So therefore, since angle A, B, C, and D are all right angles, ABCD is a rectangle. So that's kind of the idea there. All right, then let's look at one more of the conjectures in your book, and this one is, if a quadrilateral has two pairs of opposite sides congruent, then it's a parallelogram. So what do we know? Whoops. So we know that the quadrilateral has two pairs of opposite sides congruent. And then what are we trying to prove? So we're trying to prove that it's a parallelogram. So let's draw a picture of this situation. Okay, so two pairs of opposite sides are going to be congruent. And so let's label it so it's easier to talk about. So this side congruent to this side congruent to this side. That's what was given to us. And then we're ultimately trying to prove that it's a parallelogram, which again means that we have to have opposite sides parallel. So we're trying to prove that AB is parallel to CD and that BC is parallel to AD. So how are we going to do this? Okay, so we got to prove parallel lines, and remember the ways that we can kind of do parallel lines was the corresponding angles, alternate interior angles, or both perpendicular to the same line. So in this case, we don't really see any angles yet, okay, but this one kind of looks like it could happen. So we could draw in our own auxiliary line to split this into two triangles, which then I think we could prove these two triangles are congruent since AC is the same line in both. So it looks like these two triangles are congruent by side, side, side. Okay, so we've got the two triangles by side, side, side. Then we would have corresponding parts. So then this angle would be congruent to this angle, which is a set of alternate interior. That would get us parallel lines. And then this angle would be equal to this angle. That's another set of alternate interior, which would give us the other lines. So let's get that into a proof. Okay, so AB is congruent to CD, and BC is congruent to AD because it was given to me. Okay, so that was given to us in the problem. And so then we're going to draw in that auxiliary line or diagonal. Okay, so we drew in diagonal AC, and we know AC is congruent to AC because it's the same segment in both triangles. That helped us prove the triangles were congruent. Okay, so then we said triangle ABC. So this top triangle ABC is congruent to CDA. So make sure you line up the correct angles. So ABC, so that was the 1 tick mark to 2. So 1 tick mark to 2 is triangle CDA by side, side, side. Triangle congruence. Because the triangles are congruent, I know angle BAC is congruent to angle DCA. And I know angle BCA, so this other set, this purple set, BCA, is congruent to DAC. Okay, these are two sets of alternate interior angles that are congruent. So AB is parallel to CD, and AD is parallel to BC. Okay, so we see those alternate interior angles. So this one with the blue one, that gave us AB parallel to CD. And then this purple one gave us BC parallel to AD. So now you got both pairs of lines are parallel, so then that proves that it's a parallelogram. Therefore, since both pairs of opposite sides are parallel, ABCD is a parallelogram. All right, so that's kind of the idea behind doing proofs. There's a couple other conjectures for you to look at, see if you can come up with a proof for them. And then here's your reference sheet, so you can get this written in on your reference sheet, so you can take a screenshot or pause the video for a rectangle, for a rhombus, and then this one, if a parallelogram has one right angle, then it is a rectangle. So then if you take a look at your lesson summary, it talks about some different things about why we did what we did today. And so we took a look at a bunch of different ways to look at parallelograms, and we kind of decomposed or broke them down into triangles. Okay, so we looked at kind of parallelograms, rectangles, rhombus. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Rectangle has 4 right angles. Rhombus has 4 congruent sides, and a square is both rectangle and a rhombus together. So it has 4 right angles and 4 congruent sides. Then one we didn't talk about is a kite. And so a kite actually has 2 sides next to each other that are congruent. And then the other 2 sides are congruent as well. So a kite is like this. So it has two sides next to each other congruent, but not the ones across from each other. So a kite is not a parallelogram. So knowing how to kind of break these apart with a diagonal is helpful because it helps you to see the congruent triangles. So if we take a look at like a parallelogram, which we did in that one example, and we break this apart with a diagonal, you see the congruent triangles. Okay, you could see that in a rhombus as well. And then here in the kite, it splits down this way. Okay, where a parallelogram, these two sides are congruent and these two sides are congruent. And then so here's a couple of things just about the kite. Okay, so one of the diagonals is the perpendicular bisector of the other. So this one is the perpendicular bisector of the other diagonal. And then you see a bunch of different congruencies happen here. So you know that AP is congruent to PC. So then this is also saying that, so if you know you've got a perpendicular bisector of a segment, then you can actually know you have a kite, because A would be equidistant from, B would be equidistant from the endpoints of this segment. So B is equidistant from A as it is from C from a perpendicular bisector. Okay, and then same with D. So any point on the perpendicular bisector is equidistant from the endpoints of that segment. So D is equidistant from C as it is from A as well, so you end up with a kite.